Yo, 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 yo. Okay, guys, Pythagorean theorem. So we are going to use the Pythagorean theorem to solve for missing side lengths of a right triangle. Now, here is the Pythagorean theorem. It is a squared plus b squared equals c squared. What I also would like for you to write down is that is the same thing as leg squared plus leg squared equals hypotenuse squared. So the C represents the hypotenuse, the A and the B both represent legs. Now you might be saying, Mr. G, I don't know what a leg or a hypotenuse is. Well, you're in luck, I'm going to tell you. So, of a right triangle, and this might be very useful to draw this picture. A right triangle has a right angle in it. Now, in the definition of leg and hypotenuse, it describes which one's the leg and which one the hypotenuse is. So you can draw this triangle anywhere, maybe draw it nice and big to help you see. If you need to draw it big so it's easy for you to see it. But the Pythagorean theorem only works with right triangles. And in this right triangle, each side has a name. It's either a leg or a hypotenuse. The two sides that form this right angle, so that would be this side right here and this side, because here's my right angle. So the two sides that actually make the right angle, those are both known as legs. So this side's a leg and this side's a leg. The side that does not, form the right angle, so the one that's actually across is known as the hypotenuse. So the hypotenuse is always this longer side that is opposite of the right angle. So the hypotenuse is the longest side, and it's always opposite of the right angle or across from it. The legs are the two sides that make up the right angle. So this is a pretty important picture to have drawn. Also, to go with the formula is leg squared plus leg squared equals hypotenuse squared, but it's more famously known as a squared plus b squared equals c squared. We will talk about how to use this and what this all means in just a minute. Okay? But you have to know where the hypotenuse is and where the legs are. Very, very important, because that's the only way to be successful. So what we use the Pythagorean theorem for is if we have again, it only works for right triangles, but if I have a right triangle, I am using the Pythagorean theorem to find out a missing side length of the right triangle. So if the right triangle has side lengths 7 and 24, well, I know I'm going to use Pythagorean theorem to figure out what this hypotenuse is. So this is my c squared right here. So because our formula is leg squared plus leg squared equals hypotenuse squared. So what I'm going to do is I'm going to take the two values that I know, and then I'm going to plug in what I don't know. Well, for this particular right triangle, I am given the two values of the legs. I know this leg right here, because this is a leg attached to the right angle. This leg is 7 inches. So that's going to be 7 squared. Plus this leg right here is 24 inches. So that's going to be 24 squared. And all of that is equal to the hypotenuse squared, where I don't know, so that's where I use a variable. I'll use c. You could use x. It doesn't really matter. But I'm using c just because in our formula it is a squared plus b squared equals c squared. Now this is what I need to solve. I have to solve for c. So this is where calculators are nice, where I'm actually going to do my calculation. 7 squared is 49. I need to do 24 squared. So that'd be 24 times 24, which is 576. And that's still equal to c squared. Now I'm actually going to add those up. So when I add these up, I will get 625. So now I'm left with the equation of something squared equals 625. Well, to figure out what times itself equals 625, I need to take the square root, because a square root is the opposite of a square. So the square root cancels out this power of 2, so I'm left with c by itself, and the square root of 625 is going to be my answer. Well, the square root of 625 is 25. So what I just figured out is that this side length right here is 25. And I'm done. There's nothing else to do. I found the length of the missing side, which is the hypotenuse in this case, and it was 25 inches. And one quick check is the hypotenuse should always be the longest side. 25 inches is the longest side, so I probably did it right. Now for this one right here, this is an example of when we are given the hypotenuse and we're missing a leg. So I'm going to use Pythagorean Theorem, a squared plus b squared equals c squared. But I'm going to plug in the ones that I know and the one that I don't know. Well, this side is a leg because the legs are the two sides that attach to the right angle. So I am missing one of my legs. I'll just use that as the a squared. It doesn't matter which leg is which. It does not make a difference because we're adding them, and you can add in any order you want. My second leg is 12, so that's 12 squared. And then my hypotenuse is 15 squared. Or 15, so that's going to be 15 squared. So here is me using the Pythagorean theorem. I plugged in all the values that I know. I know one of the legs. I'm missing a leg, so that's why I just used a squared. And I plugged in my other side lengths. Now I can actually square them. So that's 144. This is 225. And now I do my steps of solving an equation. So I got to subtract 144 from both sides. So this is an equation. I'm solving for a. So I got to do the opposite by subtracting. Okay, so all of our equation skills and our equation abilities matter right here. So when I subtract 144 from 225, I get 81. So I'm left with a squared equals 81, so I got to find the square root, and I get 9. So that means this leg right here is a side length of 9. So 9 squared plus 12 squared equals 15 squared, and I am done. Okay. Now, sometimes you'll get these problems that look kind of weird. Like this looks super complicated. But really what this is this is just the Pythagorean theorem, maybe multiple, you have to do it a couple times. Okay, so here's what I mean by that. So we have a box used for shipping. It measures 6 inches by 6 inches by 20 inches. So here's my dimension, 6 by 6 by 20. What is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number of inches? So it's asking for the length in R right here. That's the tube that's going to go all the way across from the top diagonal to the bottom diagonal. So I want to know in this three-dimensional box, what's the length of this line that goes from here to here? That is this line R. Okay. So if I want to find out this length, this is the hypotenuse of a right triangle. So here's my right triangle that was created. So I'm going to redraw that over here on the outside. So here's my right triangle where I have S and I have R. Well, and I know this side length right here because we said the height is 6, so I have 6. So I have two missing sides here, so I can't really do anything yet. But what I could do is if we notice S right here, and I'm going to take off this purple real quick because I just kind of, I don't need to actually do that. If I notice S is the side length, is the hypotenuse of another right triangle. So this is two problems in one. If I see this is a rectangular box right here, is also a right triangle. So I'm going to draw that one in orange. And the hypotenuse is S. Well, I know this side length because this width is 6, and this is 20. So I can do Pythagorean theorem on this triangle to solve for S. Once I use S, I plug it in here because I know it, because that's the same side, and then I can use Pythagorean theorem to solve for R. So it's really just two problems hidden into one. So here's what I want you guys to do. Since we haven't done one on our own, I want you to use Pythagorean theorem and solve for S in this orange triangle over here. So use Pythagorean theorem over here to solve for S in this orange triangle. So pause the video, try it on your own, use a calculator, and set it up, because we have to know how to set it up. Okay, so it's a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. Well, my two legs is 6 and 20. So that's 6 squared plus 20 squared, and all that is equal to my side length of S squared. Well, that's 36 plus, that's 400, sorry. My pen slipped. They gave me 436. So that means to find s, I need to find the square root of 436. So I'm going to find the square root of 436. And right now, you guys just so you know, I'm plugging that into a calculator. Okay. So I got 20.88. Okay. So we got s is equal to 20.88. Now, for this, if we notice, it tells me that I have to find the 2, and it must be a whole number of inches. So here's what I'm going to do. Instead of using 20.88 for my s, I'm actually going to go backwards a little bit, because I already know what s squared is, right? S squared is 436. And that's what I got right here, right? Because when I simplified, instead of me simplifying it now and actually finding the square root to figure out exactly what s is, I know that s squared is 436. Well, if my Pythagorean theorem is you take the leg squared and you take the hypotenuse, which is s, you take the other leg squared and then you add those together, I already know what s squared is. If I take the square root and I just square it again, I'm going to go backwards to 436. So I'm just going to leave it as 436. So when I set up my second one here, this is 6 squared plus s squared equals r squared. And I'm sorry, s squared, I'm replacing the s squared because that's s, with 436. So now I have 36 plus 436 equals r squared. This gets me 472 equals r squared. When I plug that into calculator, I'm going to get like 21.7 approximately, right around 21.7. Okay, so because it asks, given that the length of the 2 must be a whole number of inches, the longest the 2 can be, we don't round this up, because 21.7 is this length from end to end. So anything longer than 21.7 will not fit in this box. So the longest in whole inches would be 21 inches. Because that will be the longest tube in whole inches that'll fit diagonally. Anything more than that wouldn't be in whole inches, and we went to 22, it would go out of the box. So, but really this was just a way to do 2 different Pythagorean theorem problems in one. Okay, so here's another one, similar. Tina ordered a replacement part for her desk. Here again, I know that this length right here is 4. I know that this length on the side is 4. So go ahead and solve for your first triangle, where we know this is s, 4 and 14. And then our second triangle is going to be, whoops, this is s, this is r, and this is 4. So again, pause it, try it, and let's at least solve for s on this first one right now. So go here, go. So again, that's 4 squared plus 14 squared equals s squared. So that is going to be 16 plus 196 equals s squared. So s squared is whatever 16 plus 196 is, well that's going to be 212. So when I set up the Pythagorean theorem over here, I now have s. And I know it's going to be 4 squared plus s squared equals r squared. Well, I know s squared is 212. 4 squared is 16. And all that's equal to r squared. This is going to get me to 228 equals r squared. So r is going to equal, I think it's like 15.1. But that's really close to 15, and it does ask what is the greatest length in whole inches, so it should have been 15 inches. All right, that is all. So things to remember, I want you to write this again. Leg squared plus leg squared equals hypotenuse squared. And I also want you to draw again. I don't care if you already have it once, having it twice will help a lot. Draw another right triangle, and then on that right triangle, label the sides. So label what the legs are, and then label your hypotenuse. And then you should be good to go. You should be able to do both of these problems. Try them out. Do not leave them blank, otherwise you will get no credit. Make sure you show your steps. That's all I got for you guys. Thank you for watching. Pretty is out.